Hi, my name is Smith Mulliken. Today we're going to be doing a little thermodynamics experiment. For this experiment, you will need a candle, a cup, access to a faucet, as well as balloons, preferably larger balloons. For this experiment, we will need two balloons, one filled with air and the other with an air-water mixture. This will then be exposed to the candle later in the experiment. The second step will be to grab your styrofoam cup and cut a hole in the top so that a candle can be placed within. The third step, of course, light the candle, place the cup on top, finally place the balloon on the open end. Now, some of you might be asking, why do you not put the candle directly underneath the balloon? This is to avoid burning through the balloon's rubbery material. This is a sample of what your experiment should look like. The second part of this experiment is going to include the water balloon that I mentioned earlier. See if you can see the startling difference in the next part. As we just noticed in the two video clips, one popped relatively quickly, while the other one did not pop at all. But why? Well, the answer actually relies on the relationships between some thermodynamic properties. For instance, P, T, and V. As we know, the heat source increases the temperature within the balloon. As the balloon temperature is increased, particles within the balloon have more temperature and therefore more energy. This causes the molecules and particles to start moving faster and faster, thus increasing the pressure. The volume did not really change all of that much. As you saw in the video, the air balloon did not rapidly grow before exploding, though there probably was a slight volumetric increase. Another major component of this is the energy. This is where another major factor comes into play, the specific heat of these two elements. What we end up using is joules per kilogram Kelvin. This means for every certain unit energy, it increases a unit mass by a certain unit temperature, i.e. the joule per kilogram Kelvin. For water, this is about 4,200. For air, it's a little under 1,000. That means that water can actually absorb about 4 times the amount of energy before it feels the same effects as air. That means that the air molecules are moving a lot faster, increasing the pressure and slightly the volume inside of the balloon, thus making it pop. This has been the experiment. Thank you so much for watching. And remember, science is supposed to be fun. So if you still have that extra water balloon lying around, might as well use it.